Good afternoon, everyone. Welcome to PDC 2008. My name is Samir Chabungbom. I'm a program manager in the JScript team in Microsoft. Over the last couple of years, I've been working on the tooling side for web developers. I've worked on providing the JavaScript installation support in Visual Studio 2008. And currently, I'm working on IE developer tools. In this talk, we'll see how web developers can write high-performance web applications. We'll look at three things. First, we'll take a look at the various components that affect the performance of script application. In particular, we'll look at the various components of IE Internet Explorer 8. We'll see how they affect the performance of the script that you write. And then we'll take a look at the IE8 JScript profiler, which is a tool through which you can measure the performance of your application. We'll see how we can use this profiler to optimize your application. And finally, we'll take a look at one of the enhancements that we have done in the JScript engine, which is the native JSON support. So like most applications, the performance of a web application depends on a lot of factors. You have the hardware on which the application is running. You have the operating system. But most importantly, because web applications run in the context of a web browser, the various subsystems or the various components within the browser do impact a lot on the performance of your script. Many browsers will have different components, different subsystems. We'll take a look at the components for Internet Explorer. So here you can see some of the major subsystems in Internet Explorer. When a user types URL in the address bar, the data will be fetched from the web server to the client through the network. It will be parsed by the HTML parser, and it will create the native object model or the DOM, document object model. The layout engine will compute the layout for various components of the DOM. And finally, we have the rendering engine, which will paint which is responsible for painting the page. The JScript engine will execute any script code in your website. So the reason for having this slide is to understand the fact that there are various subsystems, various components within the browser. And if you want to write a high-performance web application, you need performance across all the subsystems and not just one of them. So what we have done internally in Microsoft is we instrumented the browser, Internet Explorer, and we run the instrumented browser through 30 websites. And what we found was this. We found that the layout and the rendering subsystem take the maximum time. So this slide may not be visible to most of you. The numbers are not important. What is important is the fact that a considerable amount of time is spent in the layout and the rendering part. So the implication of this is that when you write your web application, whatever web application that you are writing might affect the you might be writing in such a way that the layout and the rendering takes a lot of time. So we'll see this through the help of a small demo, which I'll bring up now. So here on the screen, you can see a sample web application which I wrote. It's a very simple application. The moment I click on this button called Fetch Data here, it's going to send a response. It's going to send a request to the server. The server is going to send me back some data, which we are going to parse. And finally, we are going to display the data in a table here. So in order to measure the performance of this application, I'm now going to bring up the IE8 JScript profiler. So I don't know how many of you here might have used the profiler. So it's available in the Tools menu. You bring up the developer tools here. So for some of you who may not have used the developer tools before, the tools provides you, allows you to inspect the HTML and the CSS on your website. It also has a script debugger, and it also has a script profiler, which we are going to use now. So I'll click on this button called Start Profiling to begin profiling the website. Now I'll click on this button, Fetch Data, which will, yes, it fetches the data, and you can see the data being displayed in a table here. The data is nothing but is the longitude and the latitude of major cities in the world. May not be the major cities, but data is not important. So you click on the Stop Profiling button, and you can see the profile report being generated here. The report gives you a list of all the functions that are being called, the number of times those functions are called, the inclusive time, the exclusive time, the time spent in those functions. And you can also see the URL and the line number. If you want more information, you can right-click on any of the column headers. You can see, it also allows you to see the average time, maximum, and the minimum time. So if you look closer now in this report, you find that this particular function called append row is taking the maximum time. You can see that it's taking more than 1 second, and it's being called 425 times. So what we can do now is we'll take a look at the source of this function. For that, I'll just double-click this line, and you can see the source definition of the function here in the script tab. Now, if you look at this function, you'll find that the scope for optimizing this function is very small, I would say. Now, this is something that many of you might come across if you try to profile and optimize your website. So what we can do is we can go back to the profiler to see the context from which this function is called. So we have the call tree view in the profiler, which you can bring up by selecting the call tree from the drop-down menu here. And it lists all the functions in a hierarchical manner, meaning if you expand a node, it gives me the functions that that particular function has called. So if you look here now, you see that this function parse response is calling the function append row 425 times. Now, obviously, this function is a prime candidate for optimizing. So what I'll now do is we will bring up the function parse response in Visual Studio and see whether we can optimize it. So this is the same source code in Visual Studio. We'll look for the function parse response, and here is the function. So let me briefly explain what this function is doing. This function will take the XML response from the server. It will parse the XML data, and finally it will loop through the data and make a call to append row, where it updates the HTML table. Now, the problem with this approach is, as I mentioned earlier, we have the layout and the rendering component in the browser. So when you make a call to append row to insert a row in the table, you actually modify the DOM, which in turn triggers the layout and the rendering to happen again, which is costly. Now, this fact is important because the JScript engine or the script do not directly involve the layout in the rendering part. But you can see that if you don't write your script well enough, then the layout and the render can be called multiple times, which is what we have done here. So what I can do now is, instead of calling 425 times this function append row, we can change it in such a way that we build the HTML string that we want to update and make an update only once, so that the layout and the rendering is triggered only once, which is what I have done in this function parse response 2. You can see that the first part of the function remains the same. We just take the XML data and we parse it. In the second part, instead of making a call to append row, I create the HTML string that I want to update. And finally, I update the DOM only once through the inner HTML property. So let us change our application to use this function. This is the place from where this function is called. So I'll change this to parse response 2. I'll now save the file. We'll bring up Internet Explorer again. I'll reload the page. Now I click on Start Profiling again. Click on this Fetch Data button. Now I click on Stop Profiling. Now, if you look now, you can see that it's now taking only about 150 milliseconds. So what earlier used to take 1 second, more than 1 second, is now taking only about 150 milliseconds. So the bottom line is that when you write your web application, just keep this in mind that there are different subsystems in the browser, and if your application is going to impact the layout and the rendering part, you better write it in such a way that the changes are kept to minimum. So let us now why is this not going? Okay. So let's now go back to the slide. So let me spend some time speaking about the IE8 JScript profiler. The JScript profiler is based on the script engine instrumentation. It means that profiling happens with the active participation of the JScript engine. I'll come to that later on when I describe it in detail. The profiler also allows you to export whatever data that you have profiled into a local file in the CSV format or the comma-separated values format. So in case you want to analyze it further in a different application, you can do that. It shows the calls being made to JScript built-in methods, which may be called implicitly or explicitly. And most importantly, when we started building the profiler, what we found was that the world of JavaScript is literally littered with anonymous functions. You find that anonymous functions are everywhere, and the problem we faced was when we profile a report, everything comes up as anonymous. And the only way to identify those functions was to actually look up the source code from the URL and the line number information. So what we have done is we have put in place heuristic logic which will try to infer and give a name to each of the anonymous functions. So in this example, we have two anonymous functions. In the first case, an anonymous function is defined as part of an object literal. In the second case, an anonymous function is assigned to a variable. And what we found was that most of the anonymous functions fall in either one of these two categories. So the heuristic logic of the profiler will show up these functions as, in the first case, as area, in the second case as foo, and not as anonymous function. And we found that this is something that is really helpful to web developers. So you might want to check it out. So performance of a web application depends on two parts. First part is the way web developers write the script code. Second part is also the runtime platform on which the script application is being executed upon. In this case, the JScript engine. So what we have done is we have also done some enhancements in the JScript engine, which will improve the performance of the web application. So what we have done is, if you look at the JScript profiler, what we have done is, it's the host that will create a script engine whenever you have some script to be executed. And the script engine, when it is in profile mode, now this is something new that we have done in IE8, in the JScript engine that's shipped with IE8 Beta 2. When it is in profile mode, it will create a logger object, which handles callback from the script engine. We'll come back to the callbacks later on. Then we have a component called a profiler core, which collects the performance data from the various loggers. It will aggregate those data, and it will create a report which is being displayed on the GUI. Now, as part of this, we have introduced a couple of APIs. So if some of you might want to write your own profiler, you can make use of these APIs. The first one is implemented by the script engine. Currently, only the JScript engine in IE8 Beta 2 support this interface. It allows you to start and stop profiling. It's called the iActiveScript Profiler Control. The second interface is the iActiveScript Profiler Callback, which is an interface that any profile logger that is interested in capturing those profile data from the script engine should implement. It has various methods. The initialize and the shutdown methods are called when profiling is started and stopped. The script compiled and the function compiled callbacks are called when the script engine is compiling some scripts. The on function enter callback is called when the script engine is about to begin a function call, and the on function exit method is called when a function call returns. So using this interface, you can write your own logger, you can write your own logger and a profiler, so which will allow you to give a richer feature set than the IE8 JScript profiler. So the second enhancement that we have done in the JScript engine is the native JSON support. Now, many of you might already be knowing what JSON means. It stands for JavaScript Object Notation. It's one of the format that you can use to transport data between the client and the server. The syntax is very simple. If you know JavaScript, you already know JSON. The syntax is, it's a subset of the object literal format in JavaScript. Here is an example. So you can use it to represent objects or arrays. Arrays are enclosed in square brackets, objects in curly braces. So what we have done in IE8 Beta 2 JScript is to provide native support for JSON. So this allows us to improve the performance of an AJAX application, which involves sending some data, sending some data between the server and the client, and where you need to parse the data and display it. So let's take a small demo to see how it impacts the performance. So we have the same application. So in our application, I was using XML as the data format between the client and the server. Now we'll change it to JSON and make use of the native JSON support in IE8 to see whether we can improve the performance. So what we need to do is, I have already written the function parseResponse3, which assumes that the data being sent by the web server is in JSON format, and we make use of the native JSON API in the new JScript engine, the JSON.parse, to convert the data from the JSON string to a JavaScript object. Now this function, JSON.parse, takes the JSON string as input, and in return it will give me a JavaScript object, which I can now directly access, here. So the rest of the function remains the same. I still create the HTML string that I want to update, and make the update only once using inner HTML here. So what we will do is we will make changes so that we make use of this new JSON. So what I need to do is I need to say that instead of XML, we pick up the JSON file. So I'll just save this. We go back to Internet Explorer. We will reload the page now. And it says start profiling. Click on fetch data. Oops. Okay. Let's just go back and see what the problem is. Okay. The problem is not here. So okay. So I think I know what the problem is. I don't think, yeah, here it is. So I forgot to change it to parse response 3 because we are expecting a JSON object, and we should be using this function. So I will just save this file now. I'll go back here. So stop profiling. We can discard this report. I'll refresh the page, and I click on start profiling. Click on fetch data now. Yes. Okay, I click on stop profiling. So if you look closer now, you can see that it's taking only about 60 milliseconds. So what used to take more than 150 milliseconds, we can now write it in such a way that it takes only about 60 milliseconds on my machine. So this is the importance of having a JSON object. So let's go back to our slides. Let me spend some time on JSON now. So we found that the native JSON implementation is fast, much faster than a corresponding JSON implementation based on any framework, or even faster than the XML-based implementation. Not only that, what we found is also secure, in the sense that most of the JSON implementation that you find in framework are based on eval, meaning you just take the JSON string, you feed it to eval, and what you get as output is a JavaScript object. It's simple enough, but the problem there is if your JSON string contains a malicious script, it's not well formed, then you can have some undesirable side effect because eval is anyway going to execute those strings. So the native JSON support that we have in JScript avoids the use of eval, meaning if the JSON string is not well formed, then all it's going to do is going to return an error saying that the JSON string is not well formed, and it will not have any undesirable side effect. So our implementation is based on ECMAScript 3.1 proposal for JSON. JSON is now a new built-in object. So in the JScript engine, it has two methods. One is JSON.parse, which we saw in the example earlier. It takes a JSON string, and it will return you a JScript value, which can be an object or an array, depending on what the JSON string is. The other method is the reverse of JSON.parse. It's called the JSON.stringify, which takes a JavaScript object or an array, and it will return you the corresponding JSON string. Now, I'm sure that making use of the native JSON support in JScript engine is going to enhance the performance of your application. Apart from this, there are a couple of other enhancements that we have done in the platform. I'm not going to go in detail about those enhancements because those are not directly related to performance. But based on the way you're writing your application, you might find that making use of some of this enhancement increases the performance of your application. The CSS selector API allows you to query the CSS styles in a more efficient manner. The mutable DOM prototype allows you to extend the DOM prototypes so that you can add your own functions and methods. And this is especially helpful if you are targeting multiple browsers, where some browsers may not support some of the DOM properties. The data URI is one thing that you can make use of if you have small resources. So in this case, what you can do is you can embed those resources in the HTML page itself, and you can refer to it using data URI. It might save you in a network round trip time. So depending on how you have built your web application, these are some of the things that you might want to explore further. So what? Just to summarize the talk, what we saw in the first part of the talk was that there are different subsystems in the browser, and the way you write your web application can impact the time spent in each of the subsystems. So if you're writing an application in such a way that too much time is being spent in the layout and the rendering part, you should probably redesign your application. You can use the IE8 JScript profiler to measure and optimize the performance of your application. And you can also make use of some of the enhancements that we have provided in the browser platform, especially the native JSON support in the JScript engine. So with this, you might find that you can write a more efficient and faster web application. So these are some of the resources that you can check out. You can always write to me at my email address. You can refer to the IE and the JScript blogs. There are a couple of articles. You can also find articles on some of the other enhancements. And you can refer to the MSDN documentation also. And yeah, you should definitely download the IE8 beta too and provide us feedback so that we can work further. At this point, if there is any questions that you might want to ask, please go ahead. Yeah.
In your example, I don't know if that's live. All right. In your example, you showed building HTML strings and then throwing them into inner HTML to parse them. If you weren't sure about what was going to be in those strings, there could be other HTML, for example, that you didn't really want to render. That's one of the drawbacks of building HTML strings like that. Now, in this case, you haven't really accounted for that in the performance difference between building DOM objects and injecting them versus strings.
Yep.
If I were to use to build those objects not connected to the document, do I pay that performance rendering penalty, or is performance significantly better if I just say a document create element and not actually attach it to the element?
Okay. So as I mentioned earlier, the question, let me repeat the question. The question is, in my particular example, we make changes to the layout, and therefore we have the layout and the rendering that come into play. The question is, what if I just change the DOM that do not affect the layout? Am I right? So how do we know how to optimize it? Now the answer to that is we don't know. The reason being, the performance of a web application depends on a particular scenario. For instance, you might find that more time is being spent in the JScript engine than other subsystems. So you will have, that's why you need to make use of a tool like the JScript profiler to make changes and see whether you're really getting the performance gains or not. But there is no foolproof formula that says that, hey, if you do like this, it's going to improve the performance.
Hi, how you doing? Just two questions for you. The first is, what's the future of Atlas support, the Atlas framework in its rawest form? I didn't see mention here. I mean, is this something that's going to continue, or is Microsoft kind of going a different direction with that? Then the other question is, with respect to the built-in methods that you mentioned here and cross-compatibility amongst browsers. I know with Atlas there was already a method for parsing JSON objects, et cetera. And so I mean, how does it work with the new methods that you created that are built into IE8 if I'm trying to use it in Firefox or any of these other browsers?
Okay. So the first one is the Atlas support. Atlas is a framework, so the Visual Studio, 2008, they support writing applications using Atlas. We don't really support it in Internet Explorer because it's just one of the frameworks. But yes, if there is something that we find in Atlas that we feel it's going to be helpful if we provide native support in the platform, that's something that we can always take a look. To answer your second question, which is the native JSON support and how do we handle native JSON support in other browsers, right? So the answer is you should check whether a particular feature is available. In this case, you should check whether native JSON support is available on your browser platform. And in case it is available, you should make use of that. Otherwise, you need to provide your own implementation to make use of that so that the API continues to work. So what we have the JSON support provided by Douglas Crockford, the JSON 2 APIs. You can make use of that. That will continue to work in other browsers as well. That is until the other browsers come up and support this JSON proposal in ECMAScript 3.1. So what we are trying to do in IE8 is that we are trying to ensure that most of the browsers do actually support this API.
Yes, I think my question might be related to the HTML table optimization that you showed. In previous versions of IE, any stringified DOM collection wasn't bindable later on. In other words, I couldn't address things inside there. Has that been changed in IE8? Can I now use a string and then also address the DOM objects? Or if I need to address them, do I still need to build the DOM by hand?
Okay. The question is, in previous version of Internet Explorer, when you have the HTML string that you want to update, so when you want to update, you have to you can do it once and you can't change it later on, right? So I'm not the right person to answer these technicalities of the DOM implementation, but if you do send me a mail, I can direct you to the right person in IE. Yeah.
Thank you.
Sorry, I do have one
Any
more.
other?
Sorry, I have one more question.
Okay.
There's this nasty bug in IE7 where, let's say you created, you have this function that you're kicking off, and that function is manipulating the DOM. And I know in Atlas you have like the add load, add init. If I try to do something, let's say an add init as opposed to add load, and it tries to manipulate the DOM before the DOM is completely loaded in IE, it throws this invalid operation error, and then it basically just crashes your page, can't do anything else. Is that something that has been addressed, or does it at least fail more gracefully now?
Okay, I don't have the answer with me right now.
Okay.
So if you send me a mail, we can definitely take a look and see if there is something that we have addressed or whether it's something that's still there.
Okay.
Yep.
All right. Thank you.
Thanks. Anybody else? Okay, thank you, everyone. So you can fill in the evaluation at this website.